So we're going to be, here we are, solving multi-step equations. And today is the first of the month. Get up, yeah, no. Sorry. You guys probably... Oh, wait. Duh, that's the date. Oh, well. There we go. Okay. So, now to actually begin, I think I might want to write out, just like last time, some basic steps, because I have a feeling we're going to need these. So I'm going to keep that out. I'm going to try and keep to certain colors. So last time we had pink and orange for that. So I'm going to have blue. And then, let's see, combine like terms. How about let's do purple. That's not purple. That's nasty color. There you go. Purple. Okay, so we have a better blue and a purple and a green. Okay. All right. I think I've got all my colors. You guys know me. I have to be very, very specific. Okay, so what we're going to write out here are steps to solve multi-step equations. And I'm going to abbreviate that. Now I want to get this part out of the way first. Oh, actually I put in this conditioner in it. Big enough. Thank you. So, step 1. This is going to be in blue. Now, this one's really important. I'm going to write it out a little different here. Oh. See, now I hate writing in pen. That's what I get for trying to make it seem cool. Distribute. All right. Now, remember, distribute means to multiply. And distribute, you'll notice that you use arrows. And you're going to distribute whatever is in front of the parentheses. You're going to distribute to all the terms inside the parentheses. Most of the time, you'll have 2 to 3 terms inside of a set of parentheses. So most of the time, you'll have 2 arrows. Okay. All right. So distribute. Step 2. I want that one in purple. Step 2 is going to be combine like terms. Combine like terms. And more specifically, I'm going to say simplify each side. Simplify each side. That kind of looks like a dark blue. Sorry about that. Okay, step 3. Oh, that's a brand new pen. Step 3 is move variables to one side. Got to choose one. It doesn't matter which one. All right. Now, we're going to do that by using inverse operations. Oops. I swear there's an S at the end of that. Now, specifically, we're going to either use adding or subtracting for this step. Okay. Now, step 4 is kind of like a twofer. It's actually what we were doing with our notes on Tuesday. So I'm going to put this one in black because then I'm going to use the same colors that we had last time. So step 4 is simply solve. Now, if you recall from yesterday, Tuesday, we had our pink pen and we said we need to remove constants first. And don't forget that that's where we used addition or subtraction. Again, we're using inverse operations. And then after we removed the constants, we then moved on to remove coefficients. Now, if by chance you guys have a printer and you've already printed out these notes, I understand that we don't have a spot for this necessarily, but I know that a lot of you guys need a list of things to do and need to keep a certain order. So this is the order we're going to be following for every one of these. I'm going to use, I have all my colors out here. Those are the colors that we're going to use. So if I use blue, that means that we are distributing, okay? Let's start off easy with example 1. Example 1 says 3x plus 2 is equal to 4x minus 1. Now, I understand that not all of our steps are going to be used each and every time, single time, sorry. So first I'm going to check my blue. Do I, and I'm going to take a look into the chat now. You can unmute if it's quicker. Do I have any parentheses on the left or the right side of the equal sign that means distribute? Yes or no? Do I need to distribute? Yes or no? Do I need to distribute? Yes or no? Ooh, silence. No, I made sure. I definitely heard a little trill. No, I agree. Last time, oh, who was it? Gosh, I forgot who had brought it up. Yes, Tuesday. Do you guys want me to draw the little line, splitting it in half like we did on Tuesday? Do you guys want me to split it down the middle on the equal sign? Yes or no?
Yes.
Yes. Thank you so much for vocalizing for me, Gage. Okay, so I agree with Ms. Montes, because I don't want to mispronounce your name, that we do not have to distribute, not on this one. So let's move on to combine like terms. Now, it specifically states on each side, and that's where people get confused. So I'm going to cover this side. Are there any like terms that I need to combine on the left side? Yes or no? Are there any like terms on the left side? Yeah, so let's take a look. We have 3x and we have 2. Can we combine those two terms? And if so, what would it be? Notifications, go away. All right. Oh, okay, that's all right. So I agree with you, Michaela. I don't have any like terms on the left side. So now keeping that in mind, let's look at the right side. 4x minus 1. Do I need to combine like terms on the right side? Ooh, come on, you guys acting like it's a Monday. Should I combine like terms on the right side? Sorry. No, thank you, Andres. So we're going to move on to step 3. Do I have variables on both sides of the equal sign? Yes or no? Do I have variables on both sides? Yes, yes, there we go. So now we're finally at a step we could do something. So it says move them to one side. So this is where we get to choose. Do I want to move 3x over here, or do I want to move 4x over there? So you guys tell me. There is no wrong answer. There's just an easier way. So what do you guys want to move? The 3x or the 4x? Yeah. Now, Gage, why did you choose the 3x? I would have gone with that one too. Or did you just choose one?
I just choose one.
Well, you chose awesome. So then tell me, how would I remove the 3x?
By doing inverse operation.
Yeah, you were absolutely correct. You didn't have to use the big words by subtracting. Yeah, so what do I subtract exactly?
You subtract 2 or 3.
3x.
3x.
Now, I'm not going to play complete stupid here. So you're saying I want to eliminate this. So 3x minus 3x is, don't use the C word.
Oh, it's x.
Well, what's 3 minus 3?
It's 0.
So it's 3x minus 3x.
Then it's x by itself. That means it's...
No, what was the answer before?
Oh, then it's
a
0.
Big fat 0, yes. So because it's the exact same thing that we're subtracting from it, it zeroes out. It eliminates. That's why I don't like the C word. Now, whatever I do to one side of the equal sign, I have to do to the other, but where exactly do I put minus 3x on the right side? Where exactly? Under 4x. There we go. Or at least I gave you guys the correct preposition. Okay, let's bring everything down. Can somebody either type or tell me, what do I write now? Starting on the left side. Ooh, man, you guys type fast. Okay, so I see a 2, and I'm going to make a really, really big equal sign because people forget it. Equals, and then what kind of x is that, though? How many x's? I see x minus 1, but how many x's is this right here? Yes. Now, do I need that one right there? No, but I'm going to write it in there just in case. Just in case. Okay, so now that I'm on step 3. Now I solve for x. I need to remove my constants. Now, I have constants all over the place. I have 2, because remember, a constant is a number without a variable. So I have 2 and I have -1. Well, which function and number do I move? Whenever it says remove constants, remember your goal is to solve for x. So I'm talking about the constant that's with x. So keeping that in mind, my pink step, tell me, what do I do next? What do I do next? Oops. -1. 1. Okay. I do want to remove my -1, but how? You are correct. add 1. Yeah, I'm going to use the inverse operations again. So I'm going to add 1, and negative 1 plus 1 equals 0. Okay, okay. Now, I think you've got it a little bit backwards, Michaela, because remember, whatever I do on this side, I have to do the exact same thing to the other side of the equal sign. So as a matter of fact, I'm going to bring this down a little bit more. So this plus 1 goes where? With the 2. Abigail, I love how you're using the adjective big fat 0. All right, so under the 2, I'm also going to add 1. And now let's bring everything down. What do I bring down? See my fast typers. 3, okay. ¿Qué más? Ooh, equals an x. So remember how I had said that that's 1x? Now, at this point, you would remove a coefficient, but I mean, technically it says x equals 3. Do I have to remove the 1? No, the 1 doesn't even belong there to begin with. So that's my answer. Okay. Easy peasy lemon squeezy. Let's try number 2. Number 2 says 8y minus 9 equals negative 3y plus 2. All right. So I'm going to bring my colors back over here. Distribute. Yes or no? Do I need to distribute? I agree, Michaela. All right. Step 2. Now remember, we're looking at both sides. So I'm going to cover up this side here. Combine like terms. Ooh, I already have a whole bunch of people saying no. Okay. What about this side? Negative 3y plus 2. Am I going to come? Nope. All right. So next step. Green. And you move variables to one side. Do I need to do that? And if so, what do you want me to move? Abigail wants to move the negative 3y. Now, I agree with Abigail. I would probably go with this one because I don't like negative numbers and I want to get rid of them. So how do I get rid of a negative 3y? Add 3. Y. Not por qué, but you know, y. So plus 3y. And I know Abigail knows the answer to negative 3y plus 3y is big fat 0. Yes, ma'am. Now, where else do I put this plus 3y? Under the 8y. Ooh. You know what? You guys are a little quiet today, but if you're going to type your answers, I appreciate it. Okay, tell me what to write now. Oops. My bad. Sorry, that's why you guys have to remind me that I'm doing something silly. There we go. My bad. Okay. I was like, that looks weird. Okay, so what do I write? What do I bring down? That is 11y. Okay. 11y, and then drop everything, right? Minus 9 equals, what do I have remaining on this side? Two. Okay, good. And I love that you said specifically that it's a positive 2. Now, do I have to write the plus 2? No. Now, if there was a subtraction, I would, just like I had to bring that subtraction down with it, okay? But now we're moving on, sorry, to remove my constant. So tell me what to do. Oh, that's all right, Christopher. Ooh, how do I get rid of that 9? Add 9 because it is a negative 9. Okay. And negative 9 plus 9 is a big fat 0. Where else do I put plus 9? Oh, yeah. Plus 9. Make sure that I don't miswrite that. There we go. And we are left with 11y equals 11. Okay, so now we're at our orange step. Remove my coefficient. Usually we use division or multiplication. If you need to, you can look back at our notes from yesterday, all of our orange steps. Tell me what to do to both sides. Who's not sure? Oh, Andres. Thank you. You know, I had an Andres at my last school. Very bright child as well. Now, we are dividing by 11 because that is the inverse operation to multiplication. Now, I'm not too big of a fan of this because it's a little confusing. So that's why we're going to go through another example. So what is 11 divided by 11? Let's see who knows this answer. 11 divided by 11. Christopher, thank you, sir. So in that case, what do I have remaining on the left side of the equal sign? Y. Thank you, Abigail. Now, again, we have 11 divided by 11. And what's 11 divided by 11? One. Thank you, Abigail. So my final answer would be y is equal, I was about to write that in highlighter, to 1. Muy bueno. Okay. I was hoping to fit another equation down here, but I can't, so I'm going to fit it over here. All right, example 3. That says 3 minus 4x is equal to 18 plus x. Okay, so I'm going to try and move through this a little bit quicker. Distribute, yes or no? Do I have parentheses to distribute? Yes or no? No. Okay, there we go. All right. Combine like terms on the left side. On the right side? All right. Do I need to move variables to one side? Yes or no? Which variable do you want to move? That's
negative 4x.
Absolutely. Engage. Why did you choose negative 4x?
Because it has a number. Because if
What
we just
kind of number?
a negative number.
And we don't like negative numbers, do we?
No.
That is a good enough excuse for me. All right, so how do I get rid of the negative 4x?
We add negative 4x to positive 4x. Or
A little backwards. I get what you're trying to say, though. It's harder to put words into motion. So we're going to get rid of the negative 4x by using the opposite, which is positive 4x. Where else do I need to put that positive 4x? Where else do I need to put that positive 4x? How many x's is this x right here? 1. All right. Man, you guys already knew what my question was. Okay, so now I'm going to put plus 4x. What happens over here? Big fat 0. All right. So I only have a 3 here. My equals. And then what do I write? Then what do I write? All right. 18 plus 5x. Love it. Okay, so I'm done with my green. Let's remove my constant. Tell me what to do. Tell me what to do next. Big friendly giant. So remember, we want to remove the constant that's on the same side with my x. Now this 3 is on the other side of the equal sign. So I'd have to say if we move the 3, we're just making more steps for ourselves. It's not wrong, but it's just going to make me do more work. That's perfectly fine, Abigail. So in that case, instead of moving the 3, we should probably move the 18. Because remember, we're trying to get x alone. Let's throw everything else to the other side. How do I move 18 to the other side? How can I move this 18 to the other side? Minus 18. All right. Now, I really have no other choice. I have to put it here. Oh, boo. This does not look fun, but I know you guys are smart bunnies. 18 minus 18, big fat 0. But 3 minus 18, ooh, do we need to use a number line? Yeah, you're right. Absolutely, negative 15. Okay. I know you guys don't like negatives, or at least Gage and I don't. What do I bring down? 5x. Okay. Positive 5x. Okay. So now I'm done with pink. Orange. Remove the coefficient. Tell me what to do. Divide both sides by. What do I want to get rid of? I want to get rid of the 5. Because what's 5 divided by 5? Uno. Good job. All right. So that means that all I have remaining on the right side is my x. Here's my equal sign. And what's negative 15 divided by 5? Negative 15 divided by 5. Negative 3. Okay, good. Now, I want to skip number 4, and I want to do one that's a little bit more challenging because we've already done like a million of that. Okay, not a million. We've done 3, all like the same stuff. I want to do something different now. I know, I am such an over-exaggerator. Drama queen, absolutely. Negative 3. So I'm skipping number 4. So if you want, you can label this 5. Number 4 is the same as what we've been doing. So this one is negative 3x minus 32 equals, negative 2 parentheses 5 minus 4x. All right. Let's move my colors over because I'm going to start blue. Do I need to distribute? Do I need to distribute? Do I have parentheses that tell me I need to distribute? Yes. Okay. So what is in front of my parentheses that I should distribute? Negative 2. Okay. So this negative 2 is going to distribute or multiply times what? 5. What does that give me? Negative 2 times 5?
Negative 10.
Negative 10. Thank you, Ian. Am I done distributing that negative 2 to all of my terms inside of the parentheses?
No.
No. What else do I need to distribute to?
To the negative 4x.
Oh, Ian, thank you so much for being super specific. All right, so what's a negative times a negative?
A positive.
Okay, so what's 2 times 4x?
Positive 8x.
Oh, yes. All right, and I'm just going to bring down my equal sign and everything else. Negative 3x minus 32. Okay, so finally we got to use our blue step. So now purple, do I need to combine like terms on the left side? Do I have any like terms to combine on the left side with negative 3x? No. All right, I agree, Michaela. What about the right side? We have negative 10 plus 8. Should we combine those terms? Nope. All right, moving on to green. What do I do? Do I need to move variables to one side? If so, what do you want to move? What should I move? The negative 3x. And Gage would probably say we don't like negatives, so that's why we're going to move that negative 3x. But how? How do I remove that negative? Oh, positive 3x. Inverse operation. That is a big fat 0. Where else do I put it, though? Under what? Awesome. Oh, what the function? I don't even know what. There we go. Okay. Tell me what to write. Okay, that is 11x. What kind of 11x? Positive, okay. And then everything else I'm going to bring down. Negative 32, my equal sign, and my negative 10. Okay. There we go. Remove constants. Now remember, I'm talking about the constant that is on the same side of the x. We want to get it out of there. So tell me, what do I do? Add 10. All right. Big fat 0. Now, what's negative 32 plus, oh, child, all right, negative 22 is equal to 11x. All right. Last step, remove the coefficient. What do I do? Divide both sides by 11. What's 11 divided by 11? Uno. But what's negative 22 divided by 11? Almost. Negative 2. Good job. I know that one was a little tricky. Thank you, Jessica. Okay, we do have 3 problems for you to do. Numbers 6, 7, and 8. So please refer to the PDF. All right, I don't want to waste too much time by writing them out right now. Oops, wrong one. That one stays there. This one moves back. All right, so I'm going to flip over my page because I want to write out some more of the examples so that you guys can do some of the practice on your own. All right, now, just in case you are not aware, let me make sure I put this up here. You do, other than the practice problems, of course, I mean, practice makes perfect. If you take a look, you also have your exit ticket, which is the Google form. All right, that's going to be your grade for today. So make sure that you do your Google form. Okay, I'll remind you at the end of class. But let's continue. Number 9. I'm going to skip over to number 9. And that one says capital K. Yes, it does matter. This is a capital K equals M over 2 minus V as in Victor, that's lowercase, squared. And it wants us to solve for M. So just like last time, I'm going to get my fusion marker and highlight the variable that we're solving for. Holy function, there's a lot of stuff going on here. Now, I want to try and see, after doing these equations, what do you guys feel I should do first? What do you guys feel I should do first? Who has no clue? Who's scared right now? And that is completely fine to admit, but I need to know what I'm working with here. So I only got a couple minutes. Who needs help? All right, thank you, Jessica. So what I would like to do, this one seems ugly, but actually our pink step. What I would want to do is remove my constant. So take a look back. You can even actually look at, this one looks a lot like yesterday's number 3. And I'm saying I need to do the pink step. So if I need to do the pink step here, what should I remove? Take a look at number 3. It's very similar. Almost looks the same setup. So in this case, is I would want to start on the outside, kind of like think of an ogre is like an onion. To get to the bottom of the ogre, you have to start peeling it away. So I want to start on the outside. Now, if I want to get to this m, that's the inside of my onion, the furthest away is actually this minus v squared. How do I get rid of a minus v squared?
Add a v squared.
Oh, yeah. Thank you so much, Ian. Add v squared. And I'm going to put it right here. Add v squared. Now, you'll notice that I kind of put it off to the side because is a velociraptor the same as a kangaroo? Not even the same time period. No. So I'm not going to put them together. The velociraptor is going to eat the kangaroo. No, that's just me. So I'm going to bring it on down and say K, and that's a capital K, plus V squared equals M over 2. Now, again, remember, I'm trying to get M alone. What's happening to my M right now? Orange step. What's happening to my M? It is being
divided by 2.
So what's the inverse operation?
Multiply by 2.
Boo, that is perfect. Now, what's 2 divided by 2?
1.
Love it. So that means my equal sign and my M. Now, you can actually write this 2 different ways. If you want to be lazy, you could just leave the 2 and the parentheses with the capital K plus V squared. Or you could see that and you're like, I need to distribute. You could also write 2K plus 2V squared equals M. Now, I want your honest opinion. Which one do you like more, the top one or the bottom one? The top one or the bottom one?
Top.
The top one? Okay. I don't care. Now, I did want to go over number at least 11 and 12 with y'all. So I'll go ahead and make a video to finish those off because I really feel like you guys need a little bit more help with this. And you guys are going to have a test on this. Not this week, probably next week. And I just want to make sure that you guys have a little bit more practice. Does anybody want to? Oh, wait, no, I need to get to my geometry class. All right, so I'll go ahead and post up the video as usual for the last. I'll actually do all 4 of those problems just so you have more examples to pull from, okay? But I know I need to get to class and so do y'all. So hasta luego. Make sure you guys exit so I can stop the video. Thank you, thank you, thank you. Thank you, thank you. If not, I'm going to have to start exiting people out of here. Okay, I just wanted to go ahead and finish off examples 10, 11, possibly 12 and 13, because I think they were scrapped anyway. So let's go ahead and continue with number 10. And we're given, this should look very familiar, y equals mx plus b. And I'm being asked to solve for m. Just like last time. Now, once again, don't freak out. We're only going to have 2 steps here. Okay, so we're going to start with our pink step. Now, just like I was telling you guys before, think of this kind of like the onion. You're trying to get to the core. So you want to start what's furthest on the outside. Now, M is my middle. Okay, that's the core that I'm trying to get to. And I need to peel away layer by layer. Now, obviously, there we we go. I don't care about the other side of the equal sign because I want everything on the other side. So if you look at mx plus b, you'll notice the thing that's furthest away from mx plus b, furthest from the m, would be my plus b. Just like last time, I want to use my inverse operation, which in this case would be subtraction. This eliminates, it's a big fat 0, and let's bring everything down. Now, I know it's going to kind of go sideways, but y minus b equals mx. Again, I'm trying to get m alone. Now, usually I'm trying to get x alone, and I know that that's kind of confusing, but m and x, as usual, they are being multiplied. Now, my inverse operation to multiplication is division. So if m and x are being multiplied, and I want to get m alone, that means I want to get rid of x. Now, just as what we had said before, 11 divided by 11, 5 divided by 5, again, 11 divided by 11, just the same, x divided by x, that reduces to 1. I'm just left with 1 m is equal to this hot mess, y minus b over x. And yes, you do have one of these questions on your Google form for today. So let's try another example because that was kind of weird. Number 11. This time, this one says PG minus H is equal to I. Sorry. There we go. Okay, so this time I want you to solve for P. Okay, so I want to solve for P. So PG, remember, that just means that P and G are being multiplied. Minus H equals I. So we would be using our same two steps, my pink and my orange. Peel back the furthest layer. My furthest layer from P would be my minus H. So inverse operation says I should add H to, both sides of my equation. So I still have P times G, and this time this became a big fat 0, it eliminated, equals I plus H. Now remember, we're trying to get P alone. Since P is being multiplied by G, the inverse operation would be dividing both sides by G. Remember, G over G reduces to 1. So therefore, I'm just left with P equals, I know it doesn't look pretty, and it's okay if it doesn't look pretty, I plus H divided by G. Let's get a couple more examples in here. Let's do example number 12. Let's see if it makes a little bit more sense. Now, again, remember that it does matter which are capitalized. I have a capital P, a capital V is equal to a lowercase n, the capital R, capital T. Now, it is asking me to solve for n. Okay. Oh. Now, this one actually isn't as bad as it looks because n is being multiplied by r, which is also in fact being multiplied by t. The thing is that just to get my in alone, it's just being multiplied by that r and t. So in that case, I don't have to add or subtract anything, so there is no pink step. All I have to do is divide both sides by RT. Because RT divided by RT is 1. So all that hot mess, PV divided by RT is equal to my lowercase n. Now, this next one, it's funny looking. I was hoping that I had my stamps with me. Let me double check. Maybe I do. Okay, I found my stamps. So we have fox, smiley, plus dog equals bird. Now, what this is proving is that a variable is simply a placeholder. The same thing that you do with your numbers that we did on the front side is the same thing that you do with your variables, which are just placeholders. Now, what you'll notice is that between my fox and my smiley face, they're side by side, so that means multiplication. And I'm adding a French bulldog, I believe, and it gives us a bird. Now, what it wants us to solve for is going to be our smiley face. All right, so this is our special one. Now, this case, I do have multiplication and addition happening here. So that means I'm going to have to use both of my colors here. So first and foremost, I would want to remove my pink. I would want to remove my addition or subtraction, which in this case would be right here. So since I am adding something, I want to subtract my little bulldog. Whatever I do to one side of my equal sign, I also do to the other. Man, these stamps are really big. I hope I have enough space. So this becomes a big fat 0. And I have my fox, times, here we go, times my smiley face, which is what I need to solve for. And it equals my bird minus my doggo. Okay, now remember, I'm trying to get my too cool for school smiley face alone. Since it's being multiplied by this fox, well, the inverse operation would be to divide both sides by the fox. So remember, fox divided by fox is just like t divided by t, g divided by g, chew divided by chew. It doesn't matter. As long as it's the same thing, it reduces to 1. So my final answer, which I don't really have space here, I would say that, okay, so my final answer would be my too cool for school is equal to my bird minus the doggo both being divided by the fox. And that would be my final answer. Now you'll notice that in the example, they had different icons, an acorn, an alarm, a button. Now I'm just showing that it really doesn't matter. If you wanted, you could use a circle, a triangle, a square, and a diamond shape if you wanted. All of these are just representations, and you're trying to solve for one of them. You guys do have your problems due on your Google form. Please make sure that you turn that in. Yes, turn in the Google form. If you did your work separately, awesome. You should have. Just